Okay, it's the top of the hour. Welcome everyone. This is a session of the Etnet working group at IETF 112. Lou Berger and myself, János Farkas, co-chair the working group. And we are thankful to Ethan Grossman, our secretary, for the great minutes and the help provided us behind the scenes. The agenda details are available at the usual place. Links are provided here as well on this slide. Next slide, please. It's a reminder that we operate under the IETF rules and policies captured in the IETF Note well. So all the rules apply, and by participating here in the IETF, you agree to follow these policies and procedures. Please check if you are not familiar with that. As a reminder, this meeting and the contributions become part of the permanent record. So by participating, you acknowledge the recording. There's a list of BCPs here highlighted that drive our operations. And in the next slide, we would like to draw attention to one of them, the Code of Conduct. It has been there before. It is, I think it's going well in the working group. Just a reminder that we expect it to behave towards our colleagues respectfully and with courtesy and professional. And next slide, please. Okay, Miteko, you have found it. You are here. That's good. And we also have the usual way of chat and Jabber combined in Miteko as well, available, and the Jabber link is in the bottom as well. The blue sheets are automatic in this electronic meeting. No need to bother with that. And please join us for the note-taking in CodeMD or HashDoc, what is the name at this moment. The link is here and also available via the materials. Please help minute-taking and make sure that your points in the discussion have been captured accurately. The agenda also available online. I think that's enough for this slide. Maybe the next one. Okay, the sessions at this IETF. Sorry for the typo. It is IETF 112. We had a joint session with PALS and MPLS working group on Monday. This is important for us because MPLS is one of our data planes, and the evolution of MPLS is being discussed in these joint working group meetings and also in weekly regular open design team meetings. If you are interested, join them too. There was a contribution presented related to DetNet, and we discussed that one here at the DetNet session as well. Please check the recording if you were not able to attend. We are here on Wednesday in the main DetNet session. Next slide, please. Okay, so this is our agenda. After this intro, we will have the OEM work items on the agenda, and after that, some data plane related contributions on pre-off bracket ordering, and the second half is sort of newer work items. First, continuing the discussion on the requirements on moving towards larger scale networks. Some people were considered in the beginning, and some solution ideas towards the end on the agenda. Next slide, please. An update on our status as a working group. We have a new RFC published on the data plane IP over MPLS. We have two documents for which publication has been requested. The DetNet bounded latency draft, and the newer one is the DetNet Yang is progressing. Many thanks to all the contributors who helped to make this step, and we are looking forward to finish both of these documents and go to the final approval procedure and get them published. We have two working group documents that are not on the agenda. We have the OEM package. There is no specific detail on IP at this meeting. That's sort of a bit later stage in the queue. First, we are working on a framework and then MPLS and then IP. That was the discussion. And the other one is the controller plane framework, on which there was an update provided on the list. Next slide, please. Okay, we have received the liaison at the end of July from ITUT Study Group 13 on work items related to deterministic communication. This falls into our scope and the work we are conducting here. So this liaison has been provided as for information to us, but as it is very closely related to our work, we suggest to respond to this liaison and discuss the details on the list. Next slide, please. Okay, just a reminder on the IPR procedures. We follow strictly the usual IPR procedures. There are 2 points when we request IPR call prior to so in the beginning, at the end, prior to working group adoption, and towards working group last call. And also we have a step that we request IPR statements to be made clear if there's a new author in a draft. Next slide, please. Okay, we have been working remote for a while, and just to remind people that our main forum is the list. So please use the list, comment, and there have been good discussions. I'm really glad for that. And we have opportunities for virtual meetings in addition to the regular IETF meetings as needed. We can schedule interim meetings as we just had recently. And we can also have informal working meetings to advance our documents. We used to do this for data plane and then for Yang, actually. Now the Yang has been completed, and the one that is ongoing, and we have a bi-weekly meetings on the, progressing the OEM work. So these meetings can be set up by the chairs, and please reach out to us if you see other topics that should be discussed or would be beneficial for the group to be discussed. Either way, in an interim or an informal working meetings, we can set up those meetings. And this was the last slide as the intro. Any questions? Okay, hearing none, then let's move to the first presentation from Greg.
Yes, thank you. Good morning. And so this is an update on our framework for operation administration maintenance in a Etnet. Next slide, please. So in 111 meeting, the working group agreed to merge part of their draft into this document on OEM requirements for Etnet service sublayer, and we welcome Balázs and János as co-authors. We continue discussing documents related to Etnet OEM in our biweekly meetings, and thanks János for leading these discussions. So there are more significant updates, as mentioned. So we integrated these requirements for Etnet subnet service sublayer. And now the requirements in the document structured in 3 groups. General Etnet OEM requirements, requirements for forwarding sublayer, and for service sublayer. Next slide, please. So among general requirements, and this is not a complete list, it's just the highlights. So the OEM sessions are between DetNet maintenance endpoints, supporting and should be able to use proactive and on-demand monitoring and measurement. And proactive is that's something that is continuous and periodic using probe packets. And on-demand, it's more understood. It's basically initiated by an operator and it has a terminate lifetime of the test session. Must support unidirectional OEM methods, for example, as continuity check and measure packet delay and packet loss. We also support OEM for bidirectional DetNet flows. Next slide, please. For the forwarding sublayer, be able to do path MTU discovery, be able to use a remote defect indicator, support monitoring levels for resources allocated for the given DetNet flow. And for example, these resources include but not limited to buffer allocation and transmit scheduler calendar. Support monitoring any subpath traversed by the particular DetNet flow. Next slide, please. For the service sublayer, so that is the part that we integrated, and it's new to this document. It's not new, it's been discussed by the working group, but in this document, that's an update. So OEM functions for DetNet sublayer, service sublayer, and support discovery of the DetNet relay nodes. And in a service sublayer, these relay nodes are DetNet nodes that implement support one of the packet replication, elimination, and order preservation subfunctions. Support the collection of DetNet service sublayer specific information, and that specific information is related to the pre-auth subfunctions and relay nodes. Support the ability of exercising functionality of packet replication, elimination, and order preservation functions. And that is really important because this is a new mechanism, and at least a new mechanism for OEM, and it requires additional special instrumentation for probe packet and ability to control these subfunctions, pre-auth subfunctions. Support the use alarm indication signal between DetNet relay nodes, and so that is important than discovering a defect on service sublayer and indicating, propagating alarm indication signal to the client sublayer. Support performance monitoring in a DetNet service sublayer with the pre-auth in use. Any questions about the requirements and the structure of the document? Because that is new as we added their section on the service sublayer, so we separated into the general and the forwarding sublayer. Yes, Lou. Lou, you have a question, a comment?
Can you hear me?
Now, yes.
Oh, okay. I muted. I did it backwards. Sorry. You have a metric section that seems a little light. My expectations are going to beef that up. While you're doing that, I think it would be good to have requirements for each of the metrics that you're talking about. whether the metric is required or not, or is it must, should, may. That's it.
Okay.
Minor comment.
Thank you. Okay, next slide, please. So while we were working on the requirements, we found several open issues that we consider not to be entirely editorial, and that's why we're highlighting them in the presentation, and want working group to discuss it. So the hybrid OEM, and that's using their classification RFC 7799, and as a OEM measurement method that combines passive and active measurements, is often represented by on-path telemetry methods such as, for example, in situ OEM and alternate marking method. And telemetry information can be collected and transported in-band and out-of-band. So the example of in-band is one of their options, trace options documented in OEM as where the information is collected in packets, either hop by hop or end by to end. So hop by hop, it's a transit nodes, IOM nodes add requested telemetry information in the data packet that serves as a trigger, and end to end is an ingress and egress only collect information. But in addition, there are out-of-band methods, so where their information is stored locally, either for direct exporting immediately or for aggregation, processing, and exporting of some calculated performance metrics. And so this out-of-band methods can be either using Yang data model, so they use in combination with a model-driven telemetry, or use some other methods well known like gRPC, Kafka, or else. So what we're asking is that the current document states that DetNet OEM may support hybrid performance measurement methods, but in our discussions, we agreed that these methods can provide valuable and important information, especially important for streaming telemetry information that's used for network analytics. And then in combination with out-of-band collection and of information provided important and valuable operational mechanism. So our proposal is to make support of the hybrid measurement methods mandatory, so to change may to must. And we understand that this discussion to be on the mailing list, and would like a working group to discuss it and come to some conclusion. So further, we're proposing splitting the requirement that combines proactive and on-demand OEM into two requirements. That just the convenience, because it's much easier to evaluate the conformance, and then when we are talking about if we need the new mechanisms, or we're doing a gap analysis and we're need to do the checklist, attribute to two separate requirements rather than just say, okay, that's this mechanism can be used for the part of this requirement that is confusing. And another is what we found is like thought is inconsistency, but we discussed it. So it's two requirements in the general session are related to unidirectional performance measurements, and they seem as duplicate. So, and yeah, actually it's like in the second, and it should be 10, not first sentence in 11. So we just want to remove the first sentence. So that's probably more editorial. And next slide, please. So we'll continue our bi-weekly discussion, and everyone is welcome to join. So these are open calls. Please comment, review the document, and we think that we're getting close to the stable document, and probably at some point before the next meeting, we'll be ready for the working group last call. Thank you.
Any comments, questions? Greg, I'd like to go back for a moment to this hybrid discussion.
Yes.
You made two comments here about one is about off path or out of band. So we have had in sort of traffic engineering, we've done a lot of out of band for the response and response messages or for feedback, so on path or in band for forward, and then off out of band, off path for reverse. We need bidirectional messaging and you're doing one-way OAM. That definition is a little different than RFC 77's 99's definition of out of band. For them, they use out of band to talk about active and passive. So when they're talking hybrid, they're talking passive monitoring versus active monitoring.
Well, 7799, they have actually the two types of hybrid, but the title of the RFC is active passive in between. Itself, there are hybrid methods that use that add some information to the data packet are hybrid because they need to mark packets as in alternate marking methods to create a flow of marked packets that identify changes in batches, and IAM, which inserts it as a minimum, inserts the header that indicates and lists of informational elements that needs to be collected and a node or requested to be collected at the node. The collection methods out of band here is interpreted as being out of band relative to the monitored data flow.
Yeah, I think we can have more discussion on this, maybe on the list. But I think your out of band for responses is something that's well established, and certainly we're going to want to support. And so the requirement all looks good. Actually, I think the text in the document is pretty good. It's really just your characterization here that I had an issue with.
Oh, okay.
The other thing is that telemetry is usually about monitoring of OAM, not the OAM itself. And you don't use telemetry in the document right now, or at least I didn't notice you using it. Actually, you do use it. Yes. I'll have to read what you mean by telemetry because the examples you gave are more about monitoring OAM than actual OAM, right?
Again, so the telemetry usually differentiate two components. So they're generating telemetry information and collecting, transporting such information. And there are protocols that used, so can be attributed or characterized as on-path telemetry information, because the other methods that now we discussed are model-driven telemetry that is based on Yang push.
Right, and that's more about getting that to a central controller or to some monitoring than to do the OAM along the data path. And I think
Right.
we're mixing those concepts and in a way that, for me at least, is quite confusing.
I'm sorry. Yes, I didn't mention because I didn't go into details of what's being discussed now by IPPM working group. So there is a very useful proposal of IOM direct export. So where the information indicated in the data packet that telemetry information to be stored for the local processing. So not to collect in a data packet, but just to originate this information. And then their processing is determined by the local policy. So it could be either exported directly from the packet to the collector, and the collector can be, again, the collector can be an ingress node or egress node of the monitored flow. Or, as you said, that it could be some controller that will use it for network analytics.
That discussion would be great to bring in here, because that's the context of how you're using telemetry. So if that's how you mean to use it, I think bringing it into the document and making that clear would be great.
Okay.
Right,
okay. We'll work on that. Okay. Thank you.
Okay, hi, Balázs Varga speaking, and on behalf of the co-authors, I will present this draft, which is OEM for the .NET Service sublayer. Next slide, please. So this draft is has the intention to collect the service sublayer specific OEM topics, and the text is targeted to be moved to workgroup drafts, and this is what Greg also in the previous slot highlighted, that some texts were already moved from this draft to the OEM framework document. This document is focusing only on the service sublayer OEM, so forwarding sublayer OEM is out of scope in this document. And we are currently at version 01. And next slide, please. The next slide is showing what is the content of the draft and where were updates made. So section 4, this is what were already moved to the OEM framework document. Section 5, dealing with .NET Ping, which is describing OEM processing at the .NET Service sublayer. So what a relay node should do when it is serving a .NET OEM packet. The new text is added based on the biweekly discussions about the service sublayer OEM challenges. So we have added illustrative example, just a very simple network, which can be very useful during discussion of OEM related issues and challenges. We have also added a subsection dealing with the .NET Service sublayer specifics, but why it is somewhat specific for OEM. There is also a section dealing with what information needed when a .NET OEM packet is processed. So this information have to travel with the OEM packet. And there was also a section added about a possible format of the .NET ACH. Next slide, please. This slide is just summarizing this new text, and this is, as I said, mainly the outcome of the biweekly discussion and the discussion on the list about OEM. So the service graph, in case of .NET, it is segmented in multiple parts because the forwarding sublayer parts are terminated at the .NET relay nodes. And there are some special characteristics of a .NET pseudo-wire because the pre-op functionalities, they are acting as a pair packet protection. And that means that all the paths in a service sublayer graph, they are active and they are forwarding traffic. And they may have a different number of hops. And as usual, it is mandatory to use the sequence number for that net service. So the main challenge is that the OEM packets must follow precisely the same path as the packets of the corresponding .NET data flow. Next slide, please. This slide is showing a possible format for the .NET ACH, Associated Channel Header. The associated channel header is used for many years for OEM purposes, but its size is limited. It is only 32 bits. And if during the discussion of .NET OEM stuff, we have identified multiple pieces of information which have to be present in a .NET OEM packet. And it would be hard to put all this information in a 32-bit field because some part is already reserved for other purposes. So the first nibble is 0001. And in the version with version 1, we can highlight that it is about a .NET associated channel header. There are in the draft some proposals regarding what type of information should be there and for what purposes they might be used. This is something up to discussion. The major conclusion what we wanted to highlight with this slide is that we need to add additional 32-bit to the ACH and create a .NET specific ACH. So how many bits for sequence number, node ID, session ID, and so on are used? This is up for further discussion. And level and flags fields are also something to be defined in more detail and to discuss. Level would be something to create OEM domains, and flags can be used, for example, to control the service sublayer functionalities for a given .NET OEM packet. Next slide, please. So with this update, we have included in the draft the proposed changes and clarifications which were on the list and during the biweekly OEM calls. We are still looking for further comments, discussion. As I said, this is a discussion draft in order to help to make text of the workgroup documents. So the target is to have a common understanding inside the group and consensus on the .NET ACH and the .NET Ping functionalities. And these are practically text, these sections to be moved to a workgroup document. And here we mean the .NET MPLS OEM document. Thank you.
Any questions? Okay, I think that last point about moving it to the working group document is something would be good to address early. If this belongs in the working group document, it should be there rather than as a separate document. I don't quite understand why it is a separate document and the flow of the two documents are not well aligned, and so having it as a separate document to me is not a positive thing. If we're going to merge it, we should get agreement from the working group and do it quickly. I know Greg is going to present next on the working group document. It'd be good to hear his opinion on that as well.
Okay.
Thanks.
Yes. Okay, so this will be a very brief update on OEM for .NET and with MPLS data plane. Next slide, please. Okay, so we received very good comments from Belos, and we addressed them. So he is agreed that everything is much better now. And thank you, Balazs. And next slide. So that's it. Yes, you just heard and seen the new proposed for DetNet ACH format, and I absolutely agree. And we discussed it with Balazs and Janos about how to proceed, and we just felt that it's need to be presented and discussed by the working group, and the working group will decide it can be merged into their working group document. So please discuss. Also, as Janos mentioned in a chair's update at the top of the meeting, their new format for DetNet ACH format was presented as joint PALS, MPLS, and DetNet working groups meeting that discuss advancement or new architecture for MPLS data plane, and that was well received. And what was the good comments is that saying that, oh guys, great that you are not asking for another first nibble, but rather use flexibility of versioning of ACH for your purposes. And there were no concerns that we need another 32-bit steps. And some comments said that, oh, now you have more space and you might increase their sequencing space, so match it to DetNet control word. That's something that definitely worth considering, but will require some more work. In general, again, what to working group to discuss whether it agrees to changing their current format that is documented in the working group document, adopting effectively importing their text and new format from the individual draft. And so I would like the guidance from working group chairs on how we can proceed with this discussion and arriving at conclusion.
Okay, thank you. It would be good to hear from the group if there's any comments and particularly objections to basically moving the technical content from Balazs's draft into the working group draft. Fan?
Actually, I have the similar question here, and also not from MPR's Open Design team. So I don't know what's the procedure of this.
Sorry, at least for me, you're breaking up. If someone else heard, Janos, did you hear the question?
Up for me for sure.
Yes, it was breaking for me too.
If you could type it in, if you cannot fix the audio file.
Yeah, Fan, if you could just type it in the question into the Jabber, or I don't know if you want to try again.
Okay, and am I audible again? Or I will type it in the chat box.
I could hear that.
Fan, you actually sounded good there. I don't know if you want to try one last time.
I'm sorry, maybe it's the voice is not good. The quality of the voice is not good. Am I audible again? Okay, I will follow up later.
Fan, if you want to try one more time, we could try it. If not, yeah, please try.
Okay. Do you hear me again?
Yes.
Okay, so a long latency, I think. My question is, what's the procedure between this new .NET ACH format imported and the MPLS open design team? Because I think they are relevant. So do we need to first follow the MPLS open design team result and then imported this .NET ACH format, or we import it first and then align with the discussion of MPLS open design team? Yeah, I think there are three things. First
Yeah.
is the discussion from MPLS working group, and the second is just the discussion of this new .NET ACH format. And the third one is to move this new format from individual draft to the MPLS working group draft. Yeah, I think the clarification of to these questions will be helpful. Thank you.
I see Stuart, so Stuart probably can answer because in regard to their open design team part.
Stuart, were you going to try to respond?
Yeah, I was going to talk to this subject. So in terms of the ownership in inverted commas of the structure of Nibble 1 ACHs, that probably belongs in PALS, which is where we created it in the first place. No one has found any use for those reserve bits in the last 20 years. So we can think about making them essentially a parameter of the channel type, which I think is what was shown, assuming we're all talking about the same thing. But I think it would be as well to sort of socialize this in the sort of PALS MPLS space, just to make sure that no one, and in particular the PALS side of it, to make sure that no one can think of any serious long-term issues for doing that. But the principle of making those reserve bits a parameter of the channel type is probably okay, which I think is what you were proposing.
So I think going to the couple of questions that were asked about, I think procedure-wise, I'd like to address those, and then Greg, if you want to get back to technical, that would be good afterwards. So we do have the joint group. We are coordinating with them. This was presented there. So that's happening, and that needs to continue to happen. In terms of the documents and what we do in this working group, I think it is worthwhile for us to document what we believe is the working group position, and then make sure we synchronize it. Right now, all we have is an individual proposal. That doesn't carry the same weight as this is the direction the working group would like to go. So if this is in fact, Balaji's document does in fact represent the direction the working group would like to go, I think we should bring it into the working group document and continue to socialize it. And as the work progresses, if it gets, it could end up getting moved into a PALS document. It could get moved into a joint document, and then we work with the chairs to figure out where it is. But we'd like to keep the process going at the same time we're coordinating. So being able to represent whether or not this is a working group position or an individual position, I think is an important step.
Although I think it would be useful to get some earlier feedback than that, so that no one is surprised and there is no and any corrections can be adopted earlier. I can't see anything wrong with this, but I just think it would be really useful to have that discussion sooner rather than later. And I don't think it really
agree 100%, but it was presented in the joint meeting. Is that not sufficient?
I must have been asleep. I was taking copious notes during that meeting, and I don't remember it. But still, I must have been asleep.
Unless I'm losing, I mean, it's
one or other of us has lost. One or other of us has lost.
I thought this was presented in the joint meeting. Maybe I'm wrong.
Yeah, I presented this part of their document. So I joined Janusz and Balázs as a buffer of individual draft, and I presented their .NET ACH format and had some one of good comments from Kiriti.
Somehow or other, it went below the radar. But anyway, I think we're probably more or less in sync anyway.
Yeah,
but your general point is correct, and I completely support it, which is independent. Well, in parallel with what we do in this working group and what we decide in this working group, we must socialize, coordinate with the joint activity, that joint design team, and we should be aware that anything we do here, it could be affected by that. For example, what we agree may be modified based on the joint agreement between the working groups, and in fact, we may take the format out eventually and run it through the PALS working group if that's the end decision. But having agreement of this working group, I think, is an important step. You've seen MPLS doing the same thing of putting together positions that are right for the MPLS working group, and then we'll coordinate between the working groups, cross working groups, to make sure we have an answer that works for all. At least that's how I'm seeing the process. And I should mention, Janos was being quiet because he's a co-author on the work.
So my only concern is that someone in PALS will remember something or other that breaks as a result of this. I can't think of anything. But that's the only concern I've got.
PALS needs to weigh in on this. I agree with you 100%. PALS needs to weigh in. And maybe the right thing is if we, DetNet, end up last calling the document, we do a joint last call. Okay, Greg, you had a comment, and we should try to wrap up because
yes,
it's hugely important. We are running over.
Brief technical comment. I believe that this is important, and so I would appreciate the working group discussion on the mailing list and arrive to a conclusion in regard to updating their working group document and with their new .NET ACH format. Their interaction to the work of Open Design Team, one of their documents that working as now its individual document of group of contributors on finally creating their registry for the first nibble after MPLS stack. And value 0 for the first, value 1 for the first nibble is reserved for pseudowire ACH, and now it's a pseudowire / .NET ACH, and based on direction from MPLS working group or direction of Open Design Team is that any new mechanism should not impede on existing functionality, and it can be used as it used currently. So to minimize interaction, so probably that means that it will use a different first nibble value for its header post stack. So with that, I can close this presentation, and let's move the discussion to the mailing list.
Greg, as author, and in fact, we'll just call you editor. You can change yourself to editor of the document, but as editor of the working group document, would you conduct a poll on the list to see if there's objections to bringing in the technical content of Balazs's document into the working group document?
That's a very good idea. Thank you, Lou. And I'll shoot an email to the working group with that question.
Great, thank you.
Okay, so this slide deck is about how to provide pre-auth for the .NET IP data plane, and I'm presenting it from the co-authors János Farkas and Andrew Mills. Next slide, please. This document is focusing on how to add the pre-auth functionality to the .NET IP data plane. It is listing the requirements for adding pre-auth, and it is also providing details how we can do that. There are solution basics described. Encapsulation are also described in the document. There is a detailed packet processing. It is also dealing with the flow aggregation topic and defines in detail the pre-auth procedures. Next slide, please. We are currently at version 01, and there were these updates in the document. It is quite stable, so there were some editorial updates, typos, some grammar were corrected. And we have received comments on the list in order to clarify that this solution is based on tunneling techniques. So this is what was explicitly added to the document. The solution creates a set of underlay UDP IP tunnels between an overlay set of .NET relay nodes. The text of the document is quite stable. So next slide, please. So just to summarize, this draft is leveraging the existing .NET data plane building blocks. There are no new header fields specified. This is a general solution works both for IPv4 and IPv6, and pre-auth defined for the .NET Service sublayer. The solution is applicable irrespective what routing techniques is used underneath the .NET Service sublayer, so any IP routing techniques can be applied. And last but not least, it does not require any additional processing on transit nodes. The document is quite stable, so we are asking for verloop adoption on this draft. Thank you.
Torlis, please go ahead.
So I think we're stuck in the discussion about the point I raised. We went back and forth, and I think it would be good to have an audio discussion about that, not necessarily here in the meeting, but let's find some time afterwards, because I don't think that I saw a satisfactory answer to the problem I raised with respect to the need to consider how the elimination function and the jitter or buffering that it necessarily creates can be integrated into any of the possible bounded latency calculi that we may use in a way that it doesn't mess up the calculations for whatever shaping, queuing, or other processing is done for the bounded latency. You were giving some explanations, but I really couldn't make heads or tail out of them.
Torles, my understanding is that your comment was regarding the packet ordering functionality draft and not regarding this draft.
No, it was the packet elimination function. The elimination function, which basically creates the jitter when the primary flow, let's say you have the A and B flow. The A has the shorter latency, B has the longer latency, and obviously, if all the flows from A come, then the elimination function doesn't really do anything, right? It just drops all the one from B. But as soon as something in A is missing, you need to forward the same packet from B, and obviously there is a lot of a jitter between A and B in kind of the differential path latency, and taking that into account in a way that we can simply drop the elimination function into the forwarding chain and don't mess up the calculus for the bounded latency of the queuing in before or after the pre-op. I think that needs to be worked well through, and it might actually require to have some buffering function in there to avoid pushing off the increased jitter into the poor calculus of the bounded latency shaping.
Yeah, let's. This is a clarification question. What does that have to do with this document, as opposed to?
Am I confused here? Because I thought this was the document.
Isn't your comment just a general statement on pre-auth, as opposed to pre-auth and IP? I mean, this document scope is.
Oh, sorry. Then I may have made that comment on the wrong document here. I apologize.
I don't think we actually have an active document. That's your comment. The base document.
Oh yeah, no. This is I was talking about Balazs' personal document.
Yeah. So is this, but this is bringing in pre-auth mechanisms that exist in MPLS into IP, and I think you're talking about the base MPLS base pre-auth in MPLS.
No, wait a second. So
it applies to, it's generally, I'm not saying your comment's wrong. I'm saying the comment is generally applicable to an RFC that we have.
And to any data plane. Yeah, not only the particular.
I think it's a valid comment. I think it's a valid comment. I don't think it's a valid comment on this document, because this document is just taking a mechanism that we already have defined and applying it in a different data plane. So I think your comment is a good one and perhaps warrants its own separate discussion, given that we have an RFC on it.
No, I think it's the right document. I think you're right that this is not specific, of course, to the it is not specific only to IP. I'm going to pull my Joker card that it's 4:56 a.m. in the morning. Sorry.
Perfectly fine. I think this is a great discussion. I would suggest that it be run independent of this document, because it's a general point. Stuart?
So I am a bit confused as to why we need to write this document. So we have MPLS DetNet written, and that includes pre-auth. And we have a document that says how you carry that over UDP/IP. So do we miss something somewhere? I mean, I don't understand why inheritance doesn't mean that this just works and there's nothing to write, but maybe I've missed something.
Stuart, I think here the main intention was to make it clear and obvious how it can be done.
So I mean, I would have thought that wasn't all that we needed to do then. It sounds like maybe it's not obvious from the original documents, just to write a one-line update to the UDP document that says, by the way, you can do pre-auth, because surely everything just follows, and we don't normally sort of micro document things that are already inherited in our existing stacks. But then maybe
I think we've gotten a little bit better about helping people understand how to use the technology as building blocks. So an informational document that says how to combine things, we've done those in other groups. So I don't think it's completely out of scope.
Maybe one more thing to add is that the .NET IP data plane document claim no pre-auth for IP explicitly.
Pre-auth for IP, but there is pre-auth for MPLS, and that's what it was carrying. So maybe you need to write a document, but it doesn't. I don't think it really needs to be more than one line to say, by the way, you might not realize you can do this. Go and read these other documents.
Even though the queue is closed, we'll go to Pascal and David. We're way over time. We're going to just, so as a heads up to other presenters, we're going to end up squeezing your time a little bit, reducing your time. Pascal, you're up.
Yeah, so I'll try to be quick. So we're talking about encapsulation, and as we talk about encapsulation, and for IP, right, we basically lose the visibility of the inner flow unless we have to dig deep in the packet. And so we end up in a discussion similar to the one we just had at RAW, which is basically what identifies a copy of the packet. The sequence number and the flow ID or something is typically what comes to mind. In that row, we kind of make a difference between the flow identification as being the upper layer UDP thing versus what goes in IP. And if you take that path, it means that you need to have IP information in the IP headers and extension headers. And here we are saying, hey, we are tunneling, and still we don't change anything, we don't add anything to the headers. And so question comes to mind, how do you find the flow? How do you find the sequence counter? I mean, all this is needed.
So first of all, sequence counters are needed only on the relay nodes. And on the .NET
Can
relay
we take that
nodes,
discussion to the list, just because we're
Okay.
way over?
Yeah.
Yeah.
So basically, my bottom line, let's take it to the list, I agree. My bottom line is there are different documents which talk about the data plane for IP. We need to reconcile this as opposed to just adopt one. We need to understand what those different documents are saying and how that needs to be combined or what.
Right, so Pascal, you're saying as an implementation guidance document, this is useful, and so you're countering Stuart's point, correct?
I'm saying it's probably not sufficient. If we really want to do something in the IP data plane, we probably need more than just a tunnel. Having just a tunnel may lose the .NET information we care about, or it's never been there like sequence.
Yeah, I think so. You actually were making a different point, and I think that's valid. Is we should leave room for true IP solutions in the future. All right, David, please go ahead. Last
I want to comment that if one is prepared to run the MPLS over UDP or over IP data plane end to end, then I think Stuart's comment is correct that there really isn't much to say. However, if one wants to imply encapsulation over only part of the path, so that one can have pre-auth over part of the path without running that whole data plane end to end, then there's some interesting stuff to done. I think Pascal's been busy, been helpfully exploring some of it in his comments.
Okay, thank you. Look forward to a good discussion on the list on this. Clearly, there's interest and disagreement, so should foster some good discussion. Balazs, you're up next. You originally scheduled for 10 minutes. Going to cut you down to 5, please.
I will do my best, yeah. Okay, so this is about packet ordering function, and I have co-authors Stefan Keres, Tobias Heyer, and János Farkas. Next slide, please. So this draft is version 2, and it is dealing with the situation that replication and elimination functions may result in out-of-order packets. And this is what the packet ordering function algorithms can correct and restore the original packet order. Next slide, please. So the document is quite stable. We have made some editorial updates since the last version. There were discussion on the list, and it is also related to what Torles commented in the previous slot. So we have made it clear that packet ordering function may cause delay variation. However, how to eliminate this delay variation, this is out of scope in this document. Dealing with the delay variation is a .NET forwarding sublayer target, and it can be achieved, for example, by placing a jitter buffer or a flow regulator like a shaping function after the POV functionality. So this is definitely worth for discussion, but this is something that is out of scope in this document, because this document is focusing on what algorithms you can use in order to achieve the packet ordering functions. We have also updated the security consideration part of the document, referring to the security document and highlighting that these algorithms does not imply new security concerns regarding the POV. Next slide, please. So we have the discussion on the list. We have made some proposed changes, updates. We feel that regarding the POV algorithms, how it is working, this is something pretty stable. We have received good comments for the previous version and updated the draft according to that. So here again, the next step is planned to ask for workgroup adoption. Thank you. Thomas.
We can't take the problem of being able to define the latency calculus for the pre-op function out of scope of when we're defining the pre-op function, right? Just hand waving and saving this is a forwarding plane function. So I think we should discuss that. So because this was always the problem with the bounded latency, that we need to have a linear model, you know, that every component we're adding to the path, you know, can be calculated by itself, and you know, not pushing off some unknown latency variation to some undefined step.
Yeah, I think this is why we have separated the sublayers. We have defined the service sublayer dealing with protection, and we have defined the forwarding sublayer dealing with latency and jitter-related issues regarding .NET flows.
No, but I mean, the point is about pushing from this document, this function, this component, some undefined, you know, latent jitter off to something else is architecturally not the correct thing. This is basically, you know, a latency that needs to be possible to calculate for this function, and then there's really the question: does it make sense then to push off the problem of how to fix these things so that it becomes linear again to some other component?
Yeah,
but we're running out of time. I sent you an email. Let's find some time to discuss this more, please.
Okay.
I think it would be very good to get a informational document that talks about how implementation should manage that issue, Torlis. I don't know if you want to contribute that or work with Balazs to do that, and whether it's this document or a separate document, you know, that would be, I think, really help the working group. It's a good issue you're bringing up that implementations need to consider. I don't think we're talking about changing any of the data plane behaviors. It's really just the calculus that essentially the controllers have to do. So it's a good implementation guidance document. So that would be really nice to hear.
Worst case, my contention is that we should consider that, you know, the elimination ordering function need to have a shaper per flow in it, like, you know, like the shapers we have associated with the queues in ATS, for example, right? The queues are what we do on the interface, and then we have the shaper for them. And likewise, the same shaper could be required, you know, for the elimination ordering function, and that would be part of the elimination and ordering architectural component. So that's the worst case.
Look forward to reading the document. Thanks.
Thank you.
Please proceed. You have 10 minutes.
Yeah, okay. Hello, this is Pony from China Mobile, and it's my pleasure to talk about the requirements of large-scale deterministic network. Next slide, please. Okay, here is the motivations. In the last interim meeting, which mainly talked about if more queuing mechanisms should be considered. The requirements were presented, and WG would like to work in the requirement draft first. So we submit the new draft and hope that it can be used as a standpoint. Compared with the presentation at the interim meeting, the new draft has more analysis about the large-scale deterministic network influence, the queuing mechanism, and based on which we put up some new requirements. Next slide, please. So let's have a recap on the different levels of application requirements. And obviously, of use case gave the requirements of industrial electricity buildings and so on. Some of them clearly specify the requirement for latency and jitter, and while some not for the jitter. So far, when providing deterministic network service, network providers always face the problem of how to match application demands to the technology. The service can be clarified. One is one kind has critical SLAs such as remote control or cloud PLC or manufacturing and differential protection of electricity. And there are also some relatively lower levels of SLA for consumer networks such as cloud gaming, cloud VR. And the user of these applications hope to have a better network experience, but they can tolerate it to a certain extent if the network quality is not so good sometimes. Moreover, such users are willing to spend more money for high quality network service. And in some aspects, because they have no industry barriers and can tolerate exceeding the upper boundary of latency within a small probability. They have relatively lower requirements for the network and may be easier to deploy. And next slide, please. And here are some deployment and application status of literally deterministic network. So we won't give so much explanation about it. Just want to show that these trials, both operators and enterprise users began to put forward deterministic requirements for the large-scale networks, but the used technologies are not exactly the same. So we can see more work is needed for network service providers to successfully sell that net type service to customers. Okay, next slide, please. This is a requirement we list according to the differential application requirements, including the tolerate time asynchrony, support the large single hop propagation latency, accommodate the higher link speed, be scalable, tolerate failures of links and all nodes and topology changes, and support incremental device updates. The next slide, please. Requirement one is to tolerate time asynchrony, including four situations. First is to support asynchronous clocks across domains. And one of DNS objects is to stitch TSM islands together, which may have different clocks and are not synchronized. So the mechanism should be able to support the interaction across time domains. The second is tolerate jitter and wander within a clock synchronized domain. Within a single time synchronization domain, different clock accuracy is expected. The large-scale network should be able to recover or observe such time variance within a domain and across multi-domains. Third is to provide mechanism not requiring full-time synchronization. It is really hard to achieve the full-time synchronization in large-scale networks when considering the diameter of network topology. And it is designed that the same performance in terms of the boundary latency and the jitter can be achieved when full-time synchronization is not used, such as the frequency synchronization used in the two trials. And the last one is to support a synchronization-based method. Due to the large amount of traffic in large-scale network, and some of them are acyclic, and not all the networks or device support synchronizations, such as ATS use per flow-based asynchronous shipper to achieve boundary latency, and the formula proof shows its effectiveness. Next slide, please. Requirement 2 is to support the large single hop propagation latency. The distance of transmission is long enough to generate a larger latency than line. For cyclic-based method, the length of cycle must be either set long enough in two buffer case or other mechanism should be provided. And requirement 3 is to accommodate the higher link speed. The large-scale network normally use higher link speed, especially for its backbone. And with the increasing of the data rate, the scheduling cycle can be reduced, which requires a more precise time control. And if the network cycle times remains the same, more data can be sent, which requires more buffer space, which impose more complex buffer or queue management and larger memory consumption. Next slide, please. The requirement for is to be scalable. It include two aspects. The increase or decrease of the network device influence the topology discovery queuing mechanisms. For example, the ultra-low latency 5G transport network would require DetNet extend to every 5G base station, which might be hundreds or thousands for one operator. For the massive traffic flows, it is almost impossible to identify individual IP flow at the DetNet plan because the larger overhead and resource reservation for massive number of flows. So flow aggregation is required. Individual flow may join and exist the aggregated flow rapidly, which will cause dynamic in identification of aggregate DetNet flow. And requirement 5 is to tolerate failures of links or nodes and topology changes. Network link failures are more common in large-scale networks. Path switching or reconvergence of routing will cause high latency of packet loss and retransmission, which is usually in seconds before the network is stable again. And it is necessary to support certain mechanism to adapt to failures of links or nodes and topology changes. Next slide, please. And requirement 6 is to support incremental device updates. Since some applications that require relatively low level of SLA, it will bring acceptable for those applications to tolerate deterministic low probability to exceed the upper boundary of latency. For those applications, some simple solutions that may be realized by update and configure the ingress and egress device or part of the network service network device are expected. Meanwhile, the critical SLA of some applications can be achieved by adding the existing or other new mechanisms and updating more service. Okay, next slide, please. Here are some proposed queuing mechanisms besides TS and interserve service. They are not included in the boundary latency draft, which will be published soon. We list them and also give some analysis about the levels of deterministic synchronization or not, the cost, scalability, and the flow aggregation. The first one is based on the frequency synchronization and multiple cyclic buffers that can be proved to provide the boundary latency and the jitter. It is used the flow aggregation and the scalability is also good. And the second is micro-burst decreasing since it can prove.
I'm sorry to interrupt you, but given the time, I think it's important to. The requirements are really good, but you don't have to discuss the alternatives out there or do a gap analysis to do the requirements. And this is going to cause a lot of discussion and argument. And it really is separate from your point about requirements. So I think having this in the presentation and the document is actually diminishes from the document. So it may be best to remove it and have it in a separate document so we can focus on the requirements, if that's okay. And in interest of time, you go to your next slide.
Okay, thank you.
Thank you.
Next steps. With more analysis and discussion about the requirements are welcome. And the people who are interested in this work, please contact me. Yeah, and any comments?
A question in terms of the relationship of this document compared to the one you presented at the interim.
With which?
So what's the relationship between the two documents? Because it's a 0-0 document.
I think this question may be discussed later after this presentation.
We can take it to the list.
Peng, I mean, the question was to you, like, is it a replacement and so on? Because in the interim, the takeaway was to develop the requirements further. I got that, but
Janos, why don't we take it to the list?
Yeah, okay.
Is the person in queue for?
Yeah, actually, I answer Janos's question, so it's a
Sure,
quick answer.
let's do it very quickly.
Yeah, because I'm one of the co-authors of this just now the 00 version. The one presented in the interim, actually there was no mature draft. So basically, the draft presented just now is the very first version of that. So that's a quick answer for that. What's being presented in the interim actually is basically a collection of the information. It's slides, it's PPT slides based. There is no mature draft based on that. There was, I mean, yeah.
Let's take more discussion on this topic to the list. And Kwan?
Then the requirements related to the queuing mechanisms. Do you consider other requirements in large-scale networks, such as reducing a microburst and enhancing the resource and the routes? Lu, do you hear me?
I did not hear you.
yeah. So my suggestion would be, if you have questions, comments to the previous presentation, then please take it to the list, and let's get started with this presentation because we are over time.
Yes, you have 8 minutes. Please
thank you.
proceed.
I will
Can you
start.
Giving your presentation?
Okay. And so this draft is also about the requirements for the wide area IP deterministic networking. Do you hear me?
So
Janos?
your slides are already shared. Can you start talking to them? I could hear you fine previously, but
Janos, you may be having a problem. Please, Kwan, please proceed with the presentation.
Do you hear me?
Yes, please proceed.
Okay, sorry. Last slide, please.
Is it only me who doesn't hear her? I see indications that she is speaking.
First,
do
you hear me?
I can hear her.
Janos?
I can hear her.
Okay, I will proceed. First, we discussed about the possible problems with the wide area IP deterministic networking. We divided it into 2 parts of the work. They are deterministic network and wide area network. For deterministic network, we should consider 2 issues. First, different surfaces requires differentiated satellite queues. For example, 400 microseconds delay is required for audio and video, but no more than 100 microseconds delay should be guaranteed by industrial application. Second, problems with resource allocation rules should be taken into account. For example, resource should be allocated for the delete, but it will lead to low efficiency of resource utilization. For the routes, the stricter latency and jitter commitment per route should be provided, and it must not change due to the network changing, especially in PREF function like the owners proposed. The latency and the jitter of the 2 disjoint routes we cannot have too big difference and cannot be changing. Moreover, inter-domain route should be taken into consideration. And the second part, For the wide area network, the two features are large-scale network and multiple dynamic flows. There will be large-scale numbers of loads and long-distance links, and they will impact on the latency and the jitter. And multiple capabilities will be existed, such as FlexE and SR tuners. And maybe multiple queuing mechanisms are provided and coexisted. And finally, there are also large number and multiple types of dynamic flows coexist. So micro burst may be emerged from multiple flows. Next slide, please. So based on the problems with the wide area IP deterministic networking, we listed the requirements based on the problems. First is the differentiated network, differentiated datalet queues of the multiple services. The datalet flows could be classified based on the datalet queues. In the figure show, for example, over deterministic service can be provided, such as low latency jitter and low latency, just low latency, and so on. Second is the large-scale network. It is required to reduce the size of the network topology and integrate the multi-capability resource to achieve the optimal datalet queues. Third is the high efficiency of the resource and the routes. Resource classification and modeling is required along the explicit path with the route with the SL guarantee, such as bandwidth, latency, jitter, and the packet loss should be provided. The last one is the guarantees of multiple dynamic flows. So shaping and the queuing processing and the aggregation of multiple flows should be provided to reduce the micro burst. Last slide. So this is the solutions considerations for the wide area IP deterministic networking. For the solutions, we suggest to solve it from three directions. First step is to locate deterministic resources. Second step is to establish deterministic routes and validate to achieve the deterministic queues. So last slide, please. So the draft is also about the requirement for the large scale or wide area deterministic networking. We welcome the comments and the discussion. Thank you.
Comments, question? Peng?
I think it's the right direction of classify the categories of levels of use case, but the problem is that whether it is the right time to be standardized now, maybe in the future more suitable, because in the previous draft we also mentioned that, but we don't give the details of it. And for this draft, I think some details of analysis are expected, since it's a little conceptual, I think. And another question is that we have two requirements draft, and I want to ask what the authors think about that. Yeah.
Yeah, thank you. So for the first question, I agree with you. Classification of the datalet service and the details should be provided. So we will do the research and provide the details for the classification of the DNet service. Not just the latency and the jitter. We will provide the clarification for the other requirements in the draft.
It looks like there's a good opportunity to discuss this further on the list. I think, you know, if we can look at having the documents be merged, that would be great. If not, if we could figure out where there's agreement and disagreement. Thank you very much. Next up. So I believe you're originally scheduled for 15 minutes. We only have 10 minutes available for you.
Thank you. Can you hear me?
Yes, please proceed.
Okay, thank you. I'm Zhong Pengdu from China Mobile, and this is the fourth version of the microburst decreasing in this layer 3 network for low latency traffic draft. Next, please. Next, thank you. This page we show some modifications. Firstly, we adjust the catalog to clarify the purpose of the draft. Our purpose is to explore the methods to decrease microbursts in the network, and we add a new session to analyze the requirement of the method to decrease the microburst. And as an example, we introduce a method to decrease the microburst. Next page, please. Okay, this is a simple test from my colleague, and we want to show this page to show that the traffic has instinct or burstiness. I will introduce something about it. The traffic pass through 4G network and fixed access network, and they are between two CPEs with GPS. A test packet will be sent every 60 milliseconds, and the test lasts about 10 hours. The minimal delay between the two CPEs is about 7 milliseconds, and the maximal delay is about 700 milliseconds, and the average delay is about 26 milliseconds. It can be observed that the IP traffic has instinct or burstiness, because we can see that some of the packets experience a long delay in the between the two CPEs. Next page, please. Okay, we introduce 3 ways to decrease the microburst. This document mainly focuses on the microburst on the interface, which is different from the micro aspects in the previous page, but they show similar characteristic. The 3 ways include the traditional IP in a light loaded network. This scenario is very similar to the situation of the last page. And the second is a TSN mechanism such as CQF. It means cyclic queuing and forwarding. And the last method is introduced in this draft as an example to decrease the microburst on the interface. Next page, please. And this page we introduce the traditional IP in a light loaded network. Network will not be congested for critical traffic only if that the critical traffic has a high priority and there is only a small amount of critical traffic in the network. However, in .NET, we want to convey more critical traffic in the network. So this traditional IP method perhaps not suitable for our mechanism in considered in .NET. But the IP forwarding has a good scalability because in most cases only per packet treatment in the forwarding node is needed. But in theory, IP forwarding can only provide unreliable connection. As shown in the last page, we can see that sometimes a long delay is caused by the burst in the network. Next page, please. The second method to decrease the microburst in the network is the TSN mechanism, such as the CQF. Of course, the TSN mechanism all can provide a reliable path through the network. In .NET network, the BE traffic will be forwarded by using the traditional IP forwarding method, and the .NET traffic will be forwarded by using the TSN mechanism. However, the TSN mechanism are much more complicated than the IP forwarding, so they cannot have a good scalability as the traditional IP forwarding does. But we think that the scalability is essential for a large-scale network. Next page, please. So we explore a third method. We are looking for a mechanism that firstly, it can have a good scalability. It is to say that the intermediate node should not do per flow process on the data plan, and it also can provide a better performance for the critical traffic. It is to say that we can provide a different treatment for the critical traffic, and then we get a better user experience. On the intermediate node, we suggest to separate the process or control plan and the data plan. Because we think that in a large-scale network, the status on the aggregated DataNet traffic on the control plan may change frequently, because the DataNet flow may contain a lot of subflows, and they are aggregated. We should not assume that a control plan on the intermediate node can interact with the data plan frequently. For example, to change a shaper parameter frequently. We think that on the data plan, some self-decision process should be supported. Next page, please. We propose a method as an example. In this method, we can do the shaping at the edge and try to keep the traffic shaped on the intermediate node. On the intermediate node, the aggregated critical traffic will be shaped again as a whole on the interface. We suggest some self-decision process in the shaping, and the purpose is to maintain a reasonable buffer depth while shaping the traffic. The first step in our thought is that not to forward the packet as soon as possible, as the traditional IP forwarding does, because we think it is one of the reasons causing the microburst on the interface. Next page, please. It's about the next step of the draft. We will call for comments and continue to modify the draft. And we also call for contributions from anyone who are interested in the work. I think this is the last page, and welcome for comments. Thank you. Any comments?
Thank you for contributing the work, and we look forward to discussion on the list. And anyone who's interested, please contact the authors or make comments on the list. Thank you.
Well, thank you.
Next up, I think it's Torlis.
All right. So this is about the title is wrong. This is about the MPLS traffic class queuing for CQF. Next slide. So the concept of text cyclic queuing and forwarding was proposed to DetNet a long time ago. That was in I really only get 1 minute. Sorry, my counter is at 30 seconds. Maybe that. Hopefully that's wrong. I'll
There's
continue.
so many buttons. I just haven't updated it yet.
Yeah, sure. Right. So so we introduced that in 2018 first as a concept, and got lost running around in IETF working groups to figure out where we could standardize this. Then we reintroduced the concept in 2021 with a new variation of that draft. So I think that's why we said let's make something that actually can be standardized by writing down how this would actually work with the encapsulation that we have an otherwise complete DetNet data plane for, which is MPLS. And so the beauty is also that it only requires some 3 to 5 values out of a QS field, and so in MPLS we're using the traffic class field. So we introduced and explained that work in the interim. So the 01 version added a co-author, and that one, thanks Andy, kind of alerted me to the problems with Yang, so I had longer discussion also with Yang expert, and I ended up removing the Yang references and text from it and replaced it with something that would allow us to carry forward the specification independent of an additional Yang model to manage it, so that we don't get that conflation of context in one document. Next slide. Okay, just a quick summary. So cyclic queuing and forwarding is an old technology from TSN that's available and used in campus industrial networks with speeds smaller than or maybe even up to 10 gigabits. It uses 2 cycles for the forwarding. The main issues is that when you go to higher speeds, the clock synchronization accuracy requirement goes up linear with speed, which also means that the cost of the clock synchronization goes up with speed, and it cannot support links of varying or larger latency, because it is synchronizing packets upon receipt based on the received timestamp of the packet, and not something in the packet. So the latency of the links has to be very small, so something like a few kilometers. So the solution, and that was even discussed in TSN, but obviously adding a packet header field is always pain, so that's why also TSN didn't want to do it. But that is really what is necessary to reduce the requirement in clock synchronization and its cost, and then allow arbitrary long wide area network links, and also links with jitter that obviously even in high speed gigabit Ethernet and other links like mobile links come through forward error correction and retransmissions at link or lower layer. So that technology is working in hardware. So we did prove that with proof of concept hardware implementation just on FPGA for that cyclic queuing, and 100 gigabit standard metropolitan and wide area network routers. So at 2000 kilometer range and less than 100 microsecond end-to-end jitter, because that was just the cycle time. And I'm not going to go in the details of how more cycles, like shown on the right, give you more variability in jitter or clock inaccuracy, but that's pretty much the reason to go for more than 3 cycles. Next slide. So why is this important? And that goes back to the 2 big challenges. The operator, we want to have a service provider class network solution for DetNet to be successful. Even enterprises want to adapt standard network operational models from service providers for anything that is larger than a building network. So we do not want to have per hop, per flow shaper state for the bounded latency. And CQF is the only relevant proven standardized option today, and this TCQF, this tagged CQF, simply expands it to the tagging in the packet as opposed to derived from the timestamp. And then, of course, the challenge number 2, and we heard that from the prior 2 talks as well. Most industrial TSN applications want and need low jitter. For example, higher jitter may introduce the need to run PTP in the network purely for client devices, add PTP stacks to the client devices to resync control loops because of the introduced jitter. And the current bounded latency alternatives to CQF have really the maximum jitter, right? So 0 queuing latency when there is no competing traffic, and maximum latency under maximum competing traffic. So tagged CQF is, in my opinion, really the only short-term option that solves both challenges. There are some other options, but they would all require new packet headers because they can't get away with just a few values to indicate the necessary, queuing state that we need to make it work. And all of these additional options don't have any I think deployment validation or standardization track record. Next slide. So yeah, so this is basically all the stuff that we could do beyond this draft, and where it gets interesting but also difficult. So and that gets pretty much to extension headers for what we want to do. So we could do one for bounded latency now for additional proposals, but I think we should be careful not to do a one-off, right? So and I maybe in the matter of time not go through all of this, but so there were other in the interim there were other options for low jitter brought up. I also published one particular mechanism last month, so feel free to read up on that. All of these options may have slightly different parameters. Mine, for example, has one timestamp and then a sequence of priorities to achieve the same calculus that TSN ATS has, so that it can be pushed back. But there are a lot of other things. Jakob Stein proposed a stochastical bounded latency solution. So I think all of this is much further out before we could successfully deploy it. I hope we can and will work on it. But so I think that puts it in a separate bucket from the TCQF, which I think is ready to deploy now if we had a standard to actually allow interoperability. So, which brings us to the final slide. Next slide, please. So here are pretty much my 2 asks, right? So, working group adoption for this tagged CQF draft. And if that cannot be adopted because there may need to be charter changes, let's try to figure out how to work through that process quickly. I don't think it really would need to be considered to be any different from the pre-off work that we're doing, which also deals with algorithms in the routers and has since we started Etnet. And then the second ask is to think about how we can get towards something like a Etnet QS design team with more regular and informal meetings. Yeah, but thanks for the working group chair slides that you'll make the WebEx available. So that's great too. Pre-off latency. Not sure if there's anything else on the QS side, and then maybe start discussing there the current drafts that we already have or want to bring into the working group for the round 1 deliverables, and then the round 2 for these new packet header encapsulations, what functionality you want to have there. All right, that's it. Thank you.
Thank you, Toras. So maybe one thought on the working group adoption, that perhaps so we are developing the requirements, and I think that goes before solution. So I guess it would be good to have a working group document and develop by a working group agreed on requirements before diving into solution.
Well, I mean, we've been on this for 4 years. This is working. We know the industry needs it. This is not necessarily covering all the operational requirements that we have. So I think any of these larger scale requirements documents would be a broader scope than I think what we do agree to be, the requirements for a bounded latency solution. Right. And remember that, we don't even have anything for the other bounded latency solutions from the management plane either. So I think there is no need to delay this can be pretty much done in parallel. And, if in my working group, the ADs even wanted us to first work on the solution in parallel, if at all, work through, the other aspects. So I think that's always in the eye of the beholder, how to sequentialize things.
So I do think we have a charter issue to work. The chairs can start working that with the AD and probably come up with some proposed text and review it, get the AD at least to agree with in principle, and then bring it to the working group for review and comment and run that process. And in that time, it would be great to see more discussion and input into in this document, and we can run those in parallel.
As I said, right, I think that and I think that was a little bit the conclusion what you took down at the end of the interim. I think it mostly applies to what I had on my slide as the second part, which was, looking into all these, novel things as opposed to the very short-term things that we've also been doing with pre-auth, and where this draft would fall into. But yeah, fine. Thanks.
Yeah, I mean, we've had the discussion before that queuing has typically not been done in the routing area, since this is, different for the routing area. We want to make sure that the ISG and the AD is fully on board with it. I think just going off and doing it without their buy-in is just going to cause problems down the road when we try to advance it through the ISG. So again, we can run it in parallel. We can run it in parallel, and certainly try to have text that is either complete or fairly mature by the next meeting.
Well, as I said, in one of the joint meetings, I think we did have the discussion. I think there were more people, pointing to the fact that the work done on pre-auth, is effectively also a QS function, and that had been started in the routing.
We can have that discussion on the list. It's not going to change. We're going to work with the AD on this, and the ISG. So I mean, we can keep talking, but we're out of time on this slot. If more discussion, take it to the list. Certainly, technical discussion, we're hoping does happen on the list. And with that, we're on our last slot. Juan?
This is about the BGP flow specification for the Etnet flow mapping. Next slide, please. So the slide listed the RFCs related to TSN data planes, including data plane framework, IP over TSN, MPLS over TSN, and TSN VPN over MPLS. So in the figure shown, the Etnet may provide the deterministic service for the TSN end system, and the Etnet IP and the MPLS flows may be carried over TSN subnetworks. Next slide, please. So we mainly discussed the requirements for the flow mapping. There are two parts of requirements for the flow mapping. The first one is the primary requirements of the controller plane for the TSN and the Etnet flows mapping. The mapping between TSN streams and the Etnet flows is required for the service proxy function at the Etnet end nodes, and the mapping table can be configured and maintained in the control plane. Second one is the aggregation over Etnet flows. One-to-one and N-to-one mapping must be supported. For example, aggregating multiple TSN streams in a single Etnet flow must be supported. So based on the requirements provided in the listed RFCs. So this document proposes extensions in control plane to BGP flow specification for the flow mapping. By using the traffic filtering rules to identify the packet and using the associated action to map the packet to the related surface. So last slide, please. So we propose to extend the BGP flow specification for the TSN string mapping to datalet flow. As we will learn, the string identification function are defined in HV. And so based on the existing filtering rules, this document proposed a new type in L2 components, flow spec type for TSN traffic filtering. For example, the mask in the mask surface data unit in mask and match string identification. Moreover, for the traffic action of TSN streams, the action is to define to accept the TSN streams that matches the rule and the mapped streams to the data flows. So this document also proposes the sequence action extended community. Next slide, please. So, and so for the datalet flow mapping to TSN stream, this document also proposes a DCW type in L3 components flow spec for datalet MPLS flows. The extended action for an datalet traffic filtering is to accept datalet flows that matches the data rule and map the flows to the TSN streams. So the document also proposes a TSN action extended community. The TSN profile can be converted to the string-related parameters and requirements, including TSN string ID, string handle, sequence number, and the traffic scheduling information. Next slide, please. So next step, we plan to present and discuss in IDRWG, and we want to get more feedbacks. Comments and the discussion are very welcome. Thank you.
Any questions, comments? We have 2 minutes. Jeff?
Thanks, Lou. I'm going to apologize. I actually only caught a portion of the presentation after I was flagged about this. I've read the draft very slightly. I do see that it is doing much work with FlowSpec. A quick word on that. The base FlowSpec RFC, which is version 1 of the protocol, is known to not be extensible. So there is work that is starting in IDR to do a FlowSpec v2. So I think you're going to find that some of your changes will probably require the FlowSpec v2 work in order to become a viable protocol component. IDR should be holding an interim on FlowSpec sometime, very likely early December, and we'd invite you to present there.
Thanks,
okay,
Jeff.
Thank you. I will. Thanks, Jeff. I will change that extensions to FlowSpec version 2, less version. But in this presentation, I'd like to get some feedback for the requirements of the flow mapping. Thank you.
Yeah, from the, I think the DetNet side, I think it's important to qualify the document that it's really focused on TSN mapping, not just generic DetNet. So making, having the document identify its scope as TSN in the title, the abstract, the narrative part, that would be important. In terms of the process standpoint, I think I think DetNet is, the DetNet chairs are happy for it to be run wherever the AD thinks is appropriate, whether that be DetNet or IDR. Sounds like it might be best to run it with IDR, given where FlowSpec is and what Jeff commented. I see he's back in queue, so I'd love to hear his opinion on this as well.
Thanks, Lou. So the first thing I was going to say is that we do have, and I'm having trouble loading my agenda, whether you're on the presentation slot or not, but if you were not a presenter for IDR's session tomorrow, we do actually have some available time. So please consider yourself invited to present if you're not already there.
And Jeff, after that, if you could let us know sort of what the opinion is of the group, and we can coordinate with our AD, John, offline to make sure this ends up in the right place. That would be great. Okay.
And last comment for you to give you your time back. Certainly in IDR, we can help look through the BGP protocol extensions, and much like other plumbing protocols, it will be up to you guys to determine whether this makes sense as a mechanism for DetNet. Thank you.
Gotcha. Thank you very much. Quan, anything else you want to say before we end the session?
Yeah, thank you, Jeff. Thank you, Lo. I will contact the Jeff to see if we would like to present.
Okay, great. Thank you all for a good session. Really appreciate all the contribution and good work. Janosch apologizes for not saying goodbye. He had some audio issues, but thank you all. And we have a chance of maybe being in person the next time, or at least some of us. So hope to see some of you at the next meeting. Bye now.